I'm Noah. I'm going to talk about simplifying radical expressions using the product property of nth roots. So some radical expressions are very easy to simplify, such as the square root of 16, which equals 4, or the cube root of 27, which equals 3. Okay, those are easy. They equal nice whole numbers. In cases where it doesn't equal nice whole numbers, you can utilize the product property of nth roots, which basically says that any number for the same index can be split into two separate numbers with that same index, and then solved. So let's take a look at the cube root of, say, 24. So you're going to try to figure out what the cube root of 24 is. You need to figure out its factors. So the first step is going to be factoring. So 24 happens to be 8 and 3, and then 8 can be split into 4 times 2, and then 4 can be split further into 2 times 2. So according to this nth root property, we can take it and do the square root of 8 times the square root of 3, which are the cube root of 8 and the cube root of 3, which gives you the cube root of 24. So cube root of 8 times cube root of 3 should be read the same as the cube root of 24. We happen to know that 8 has a good cube, which happens to be 2. And then 3 does not have a good cube because nothing times nothing equals 3. So you are left with 2 cube root 3. So that's your final simplified radical expression. You can also notice this by taking it and going, okay, I have 1, 2, 3 2's. So since I have a set of 3 of 2's, I can pull out the 2, and I have 1 remainder of 3. So this is why the first step is to factor. So that's this tree. The second step is to remove sets matching the index. So in this case, we're looking for an index of 3, so we need sets of 3 of any number. So in this case, it happens to be 3 2's. So you pull out your 2 with the remainder of a 3. You can also simplify radical expressions using variables with this. Let's look at the square root of x to the 5th. So I'm guessing that doesn't have a really easy square root because nothing can be times by times by times into 5 twice. So factor it, so it's x times x times x times x times x 5 times, so there's 5 factors of x. We're going to look for sets that match the index. So in this case, the index is 2. So sets of 2, there are 2 of them. So you have x to the second square root remainder of x. Final example of simplifying a radical expression, it's a little complex, can be division problems. So let's say you have the square root of 9 m to the 5th n over 36 m to the 3rd n to the 9th. Okay, so in this case, you're going to treat it initially like a regular division problem, so a regular fractional problem, and you're going to forget about your root for just a second, and you're going to simplify things. So your 9 into 36 can simplify into 1/4. 9 goes into 9 one time, 9 goes into 36 4 times. So you have 1 over 4. And then you can simplify your variables because we know with the exponent rules, you can subtract the bottom from the top. So in this case, we're left with, you got 5 n's on top, 3 m's on bottom, so it's going to leave you 2 m's on top in the positive. For the case of the n's, you have 1 n on top, 9 n on the bottom. So if you subtract that from the top, that's going to leave you with a -8. So you don't want negative exponents ever in the top. You don't want negative exponents at all. So you kick that back down to the bottom. You have n to the 8th. Now you got to bring over your square root sign. So this whole problem is square root. So now you can use the product property and you can say, okay, so this is the square root of the top number divided by the square root of the bottom number. It's going to look like this. Square root of n m to the second divided by square root 4n to the 8th. Now, you simplify your radical expression by factoring and removing matching indexes. Can't really do much with the 1. There's no square roots for 1, but there is a square root for m to the second. You take this number here, divided by this number here, and it's going to leave you with 1m on the outside, square root of 1. Now on your bottom, you have 4 does have a square root, happens to be 2. 2 times 2 is 4. And then you have n, well 8, well you can move out a nice common number of 8. So 2, you divide 8 by 2, and that leaves you with 4. So you have n to the 4th, no leftover factors, so no square root sign on the bottom. So this is your final simplified equation. And that is simplified radical expressions.